They really did a lot of background stuff, I guess is the way of putting it.
Yeah.
I remember my character was the Baron of Gwynedd, which is a little region on the Atlantic Bay. And there was the threat of the Glory Usurper, which we wrote about, and various times had more or less, lore written about it. But it was all really backstory there wasn't a part where we were like, let's play the game of Daggerfall as player by player.
Yeah, I see. That makes sense. Well, you also used to do some role play with some people on the forum, where you would role play Sheriff Roth. So, I mean, did many stories? Did you like develop his character through those sessions, and like, were there any stories that came out of that?
I guess the short answer is not much. It was really fun to do, and I'm still in contact with some of the people that I did that with. I think the only thing for sure that came out of it is a brief reference. I was hired to do the second pocket guide to the Empire, and I wrote in some stuff that came out about what happened on Somerset Isle with because it was never resolved. You mentioned earlier the tribunal original concept, because it's kind of covered at the end of fandom. You have to have played. You have to deep dive into Daggerfall to remember or care about what is her name?
Princess.
What?
No, I don't think that's the right person.
Brenzia's daughter. Elspeth is her brother.
Because both mostly so access to the loops in this case, but for mostly characters that incorrectly conditions due to incorrect use.
Basically, him offering her assistance in her getting married off to the king of First Hold on Somerset, and in return, she was promising the king of Worms her first. And
it's another thing you can sort of explore in the narrative, which is really good.
It's a super
Christmas,
very but really interested.
God, if someone did that now, it would just blow my mind, and they just like continue that storyline somehow. That would be so cool.
Yeah. So I did make a reference because we explore that role play. I played her first, also in addition to Sheogorath. And
Chris look to return
referred to him as being the current king of
label functions in the
it was a character who came out
she
there.
considered personally label all the functions that call the previous day to that single command ancestor. So result we obtain something that call which is also active. We assume that the value is modified and returned by labeled calling functions can be arbitrary but must satisfy the contract assumption. In addition, the context of calling the function is labeled subject can be arbitrary but must satisfy the contract assumption. If all the conditions in path passing through the edges into that are either feasible or runnels by the definition given above or with a buffer over error. Key access and set of edges is called none of the edges from certain critical set can be detected deleted without seeing this property, then it's called critical set. I know that some of the run is bad.
But I always thought like
it can be generated certain paths satisfying
that thing where and it's perfectly
there is minimal error. Let's see.
So obviously I named him after myself. So I
that's cool. So do you like, because obviously Gregor character's changed quite a lot in modern games. Do you like how he's changed, or do you think like you would have written something different?
Fun.
Good afternoon. Let's start. Okay. So today we are going to look at the different technique to actually class of techniques to sort elements. So we understand if we want to use compression to sort elements, and the best we can do is analog GAN, right? So we look at a few of those techniques, and a few of them have achieved the best performance we can hope for, and the basic case merge sort and also heap sort. Then we look at a quick sort. Quick sort in general cannot achieve the best performance. However, on average, in general practice, it will always achieve very close to the optimal performance. That's analog GAN. Okay. So if we can do better, and why don't we just use this type of technique? Unfortunately, not all the problems are suitable for this type of techniques. Okay. So in order to achieve linear time complexity, we need to have some kind of assumptions. That means we need to know what kind of things we're trying to solve. Okay. So in the first case, we have a technique called a counting sort. And so the assumption is all the elements they are within some kind of tight range. Okay. So let's say we have n elements, but they are within this range. Okay, 0 to k. And of course, k can be greater than n or smaller than n, but in general, they should be close enough. You can't have a wide margin. Okay. So that is something you need to keep in mind. Okay. So in order for this type of technique to work, you have to have some special properties about the problem you're trying to solve. Okay. Any questions so far? Okay, all right. Okay, so now, so if we don't look at the comparison, if we don't use the comparison, and how do we do that? Okay, so now by its name, it's counting, right? That means somehow we need to count something, right? That's exactly why we get the name for this technique. Okay, so we're going to count how many elements are of the same value. Okay, and how do we do that? And simply we use some additional arrays here, additional storage to help us to achieve that. Okay, so we're going to look at this algorithm. Then I'm going to show you the example, which will help you to understand what's going on inside this algorithm. Okay, and sometimes it might be a little bit confusing because you see all these indexes, right? You have somewhere array and C is inside it, and then A is even inside C. There's like 3 nested levels of array indexing. Okay, so it's gonna make sense a little bit awkward, right? So we'll see. Actually, in principle, it's not that difficult. Okay, so first try to of the same value. Okay, so let's say if we have value 5, we want to see how many times occur in this list to be sorted. Okay, and of course, if they're all distinctive, we only have one, right, at most one. Okay. Okay, so we're given array A that contains the original elements, and we have another B array of the same size. We want to output the elements. Okay, so in other technique we have seen, we simply rearrange the elements in A, right? In this case, the order is destroyed, but here we want to maintain order. So the input is still there, but we just create another array B for the output. Okay, so that is easy to understand. Okay, we also have a parameter K, which tells us the largest possible value of the elements in A. Okay. And so that will give us some idea what kind of storage we need in order to count all the elements. Okay, so here we simply use another array C, and which try to count how many elements of the same value in A. Okay, so that is the basic idea. Okay. So line 1 and 2 is very easy to understand. We simply introduce a new array C, we initialize that, every element is 0. Okay, so that is easy to understand. Okay, so now we start counting. Okay, so here we start counting line 3 to 4, and 5, of course, is just a comment. Okay, so we're going to go all the way to the very end of the array, and then we start counting. Okay, so now how do we count? Okay, so basically the value of A actually is used as index for C. Okay, now can you understand line 4 here?
Cool.
Professor, what do the backwards arrows mean?
Oh, that's assignment.
Okay.
All right.
Replace it, yeah.
And that's working.
That's an equal sign?
Yeah, if you use a like, you can use equal sign like C. Otherwise, probably use a code and equal sign.
So with the index CA plus 1 means I have to roll 1.
Yes, you know. This is another one. It's weak, it's weak, that's weak. The rest of this is 0. So it's not so it's not right. So the reason this is you have to this is the people you have. Okay, so this is an index, and then we see one can handle. Okay, so let me go back now and understand what the value well, okay, after the result. So understand now this is a line 3 and 5. It's not even say that. Okay, now 7 is it's actually now we exactly remember this is
So I can just leave that on top.
so what happens here is you just add putting this up, right? There's 3 twos, then 4 wins, right? this part. Okay, so you start the first position 5. So there are 4 ones here, right?
It's 9 pages, just a little bit.
6 and 7. Okay, go back again. Here. Okay, so this part, right? You know how to count. Where's that? Now, yeah, let's see, you know, we can also say we have album, which is what, where is sub? And how many albums are less than 2, right? That's 2, right? You can see how where the zeros, right? And so, since we don't have any words, so you add and these two get
Definitions of the error.
and then you add further these two together, and this is what right? You see that? If you add it together, it will be this guy, right? And then you add everything. So the last one will be the last one of the history. But this tells you basically the solution. You guys start? Okay, so you understand start. Yes. It's alright. You can hear?
I can hear you.
Okay. So this tells you the resolution. For example, here, let's say if you have 5, that way, right? Since you have 8, right? And
Okay, so you upon replacing it, so you consider a set P of is it feasible? There's this one. P prime set some experience be the novice set of CSG.
And use that index, right? But when we see how to get the so now this stuff is actually
Physical thing with really assumption definition of interpreting this following the need table for the pattern that satisfies one condition. It contains an instruction affecting the buffer of the sector by the index I on any corresponding concrete path the value of the variable I before this instruction does not follow the interval. So this one concrete execution path corresponding to this path on the assumption that the set is and all variables can take any combination of values. Therefore, it was shown that if the contract of certain function satisfies the contract assumption, then the two of following application holding this function satisfies the given condition, then there is a potential context of calling this function which is suitable for this contract, in which execution of this function causes buffer overflow. Whereas if there is a calling context which the execution process through each package loop of less than level n no more than KTD times can cause buffer overflow. This function satisfies the given condition. We give the roller graph J K instead of the real CFG, and it passing more than K to the n times the packages of the loose nesting. And I know this is significant limitation because fair balance is going to terminate access in this case, but we will almost the finite iteration that the incorrect loop conditions are upon exiting of the loop. The incorrect case of the induction variable selection 3.4 describes some heuristics that allow one to work on the limitation of the introduced model definition of an interpreted error. Consider a path P in GK to satisfy the definition. Definition given above that is path before this path is certain final is P I given the edge needs to buffer access section Q access. Commission or select between subsequent in layout of functions. In a call graph that contain edges from this sequence and recursively label all the functions that call the previously labeled function up to single command ancestors are resolved within a level subgraph of the call graph, which is also a tree. Assume that the values modified and returned by a level calorie functions can arbitrary but must satisfy the contract assumption. In addition to the context of common word function labels, subtree can retrial must satisfy the contract assumption. So that this condition will path passing through the edges are either feasible or run by the definition of a buffer or then the set of edges is called the critical set. If none of the edges from a certain critical set can be without loss its property, that set is called the minimum critical set. Now that for some right path more than one minimum critical set can be generated. So if we're certain passive and there's no meaning. Ethical set consisting of playback the edges of a single function that is called a procedure or whatever. For the detection approaches considered in this paper is symbolic execution with state merging, that is formulating the problem of interprocedural overflow detection in terms of symbolic execution. It's a vector of symbolic variables. We can use a vector of a non-variable C. The condition for reachability of an arbitrary QB axis a path P is that P is fine as each card PQ vector. The condition for occurrence of phenomenon from mirrors that uses function buffer. So I see it's can be region as whatever. I need to get my set.
Almost definitely. Well, let's look at next time we do one. Next we'll the way over here, right? We get next right? So we see, so we got put these two elements in their partial limits, right? Already here we got the opposite, right? So these we got in the like this. Okay, so next three and three is here. Look at this one three. Now it takes the two six, right? And so go here and we introduce by one.
So exist P set P, exist vector U, which column P Q access vector U. 1000 and length and lower. Cast okay. BSQ. Cast instruction, cast X. Castro. Condition directive. Let's consider the detail of summary. Find out whether this air condition can be set for these elements. Summary Castro. Beep of the definition constant value comes from the set for public place. Equals B some include set constant and right here. Then HB is Vx equals B cosine land and gag regular equal x. LV is B. So where is this? Forgot. X equals B. Obviously, it's going to be the condition of transition. Current by hence we can derive that the sufficient condition that is considered these conditions by example of strict comparison. Suppose that P equals B as comp sets relations as comprehend straight line set somewhere. Static symbolic execution. Being greater than land HB as comp x minus 1 B as B x equals false upper boundaries non B. So that stuff barely see consider the conditions and sufficient condition HBF. So suppose that SB so that for certain x it is prepared to prove that the control point which is given point where certain is path y x equals a minus b greater than x and any concrete path corresponding to it. Now that for any a gec or b set we have a gec then a and b gec then b and a minus n prime. Therefore, the SFG path specifically this point is subject to years. So that A and B neck and A between Greek. X A exists B exists A exists B LB. The cool stuff. This is expected not to take more than 2 hours. So you can use all types of it. For certain B at a given point Q, the mapping is not defined, and there's no information possible about the bottom expansion of the function and we can be extended. Each values in some ways so they acrylic graph. Direct cyclic graph. All nodes of this graph are also limits of summary, so limits values constant. This question is an example for example. Let us employ the proposed approach to detect the overflow errors in the function bar. For convenience, we use identifiers rather than the region variables. C9 A1 C9 okay. Join A1 okay. A1 so constant C1 1 and A2 9 Buffer access instruction exceeds process of manager buffer opening 10 with the check condition. Okay. I think this is what I can do. Okay, got the info. Let's see if I can even write about this. Satisfied because it holds